Hello and welcome to this video in which we shall discuss the third lesson on logarithms, log laws. We previously discussed the power rule of logarithms, which is that if we have a log of x to the power of r, the log kicks out the power and we can write the r outside on the left as such, and we end up with r log x, regardless of whether there is a base or not. This doesn't really affect the rule. We can have a base or not have a base. That's not very significant here. And we gave two examples, one with a base and one without. So log base 4, 5 power 3 kicks out the power and becomes 3 log base 4, 5. And another example without the base, if we have log 6 power 3, we take this to the left and we get 3 log 6. Now, we will study two new rules in our dealings with logarithms. The first rule says log xy. Again, we don't care about the base very much. So log xy is the same as log x plus log y. As an example, you can check on your calculator log 15 and log 5 plus log 3. You will find that these will give you the same result. Why are they equivalent? This is because 15 is 5 times 3, and log of 5 times 3 becomes log of 5 plus log of 3. So if we have two numbers or elements multiplied inside a log, we can create two logs, one for each element, and we add them together. Similarly, if we have two elements that are divided by each other, log x over y, this is the same as log x minus log y. And this works with or without a base. So if they all have a base a, this doesn't really change anything. So for example, if we have log 15 over 4, this is the same as log 15. This is a mistake, sorry. So log 15 minus log 4. Let's try some examples. Write the expression below as a single logarithm in simplest form. So in 25, we have 2 log base b 2. Now, just like the log kicks out the power, if we have a number outside of the log, we can remove it and put it inside as a power. So instead of 2 log 2, we have log base b 2 power 2, which is the same as log base b 4, because 2 power 2 is equal to 4. Another example is 2 log base b 7. Again, this can go in, and we have log base b 7 power 2, which gives us log base b 49. Because 7 power 2 is 49. This has to do with the power rule and how it can go in and out, depending on whether we're trying to condense the logarithm, we want it to be one term, or we're trying to expand the logarithm, as we will later see. Now, for the third example, we have log base b 4 plus log base b 2. Now, if we have log plus log, we can write them as a single logarithm with the same base, and we can multiply these two elements. We have 4 times 2, and we know that 4 times 2 obviously is 8. So we end up with log base b 8. For the fourth example, we will have to use two different rules together. Now we have 2 log base b 6 minus log base b 2. So the first thing we do is we take the power from outside and we put it inside. Now we have log base b 6 power 2 minus log base b 2. If we have a minus sign, we can rewrite them as a single logarithm, but we have to divide the two expressions. So we have log base b, 6 power 2 divided by 2. For 6 power 2 divided by 2 gives us 36 divided by 2, which is 18. So therefore, the final answer will be log base b, 18. For the final example in this page, write the expression below as a single logarithm, log base b6 minus log base b3. So again, we can say log base b 6 over 3, which is log base b 2. Therefore, the final answer here would be log base b 2. Let's try some more examples. Again, we are asked to condense the logarithm. So log b, so here we don't have base. That's okay, that doesn't matter. Log b plus 2 log c. So first thing I have to do is I have to put the power inside, and we get log b plus log c squared. Now we have log without any numbers outside. We can just compress them into a single logarithm by multiplying the expressions inside the log. So we end up with log bc squared. Let's try another example. We have log d minus 4 log g. So first we take this 4, we put it inside as a power. We end up with log d minus log g power 4. Now we can compress. Since this is a minus, we divide the two expressions. So we get d over g power 4. For the final example, we have two numbers outside, which are c and y. We have to take them inside as powers. So this becomes a power c and b power y. Now we have a minus sign here, so we have to divide. So log a power c divided by b power y. Remember, first thing you do is you have to take the numbers outside and put them as powers inside, and then if we have a plus, we multiply. If we have a minus, we divide. So this is how we interact with condensing logarithms. Now we're going to try the inverse or the reverse process, which is to expand a logarithm. Now we have log x power 4 over y power 3. So if we have two terms that are divided by each other, we can rewrite it as log x power 4 minus log y power 3. But they don't want powers, they want just log x and log y. So we can kick out the powers. We get 4 here and 3 right there. And our final answer becomes 4 log x minus 3 log y. Let's try a second example. Log 7x power 3. So here the power is only affecting the x. So you cannot just kick it out because it's not affecting the entire term of the log. So this would be incorrect. First, you have to split the log into two logs. We get log 7 plus log x power 3. And now the power is affecting the entire term inside the log, so we can kick it out. And this becomes log 7 plus 3 log x. However, had you kicked out the power from the beginning, you would have obtained 3 log 7x, which would have been 3 log 7 plus log x, which would have been 3 log 7 plus 3 log x. And this is not the same result. You have an extra 3 here, which is incorrect. This is the correct answer. For the third example, we have log x squared over y power 5. Again, you don't take the powers outside. You first subtract. You say log x squared minus log y power 5. And then you take out the power of each, and you end up with 2 log x minus 5 log y as a final answer. So we're going to move on to harder problems now. For example 6, we are given 3 terms, not 2. So we have log root y power 5, z power 4 over x power 5. So anything in the numerator gets a plus, anything in the denominator gets a minus. So the first step is log root y power 5 plus log z power 4 minus log x power 5. And then we want to be able to handle this term which has a power and a root. Remember, in a previous video, we said that root of x is the same as x power half. So root of y power 5 becomes y power 5 all power half, which is y power 5 over 2. So instead of root y power 5, we can rewrite this as y power 5 over 2. And then we kick out the powers, so we get 5 over 2 log y plus 4 log z minus 5 log x. Let's try one now without the root. We have log z power 3 over y squared x. So we have log z power 3 minus log y squared minus log x. Remember, any term in the denominator has to take a negative sign. So 3 log z log root y power 3 over z power 4x. So we have log root y power 3 minus log z power 4 minus log x. And like we said before, this can be handled in a better way. So root y power 3 is the same as y power 3 all power half, which is the same as y power 3 over 2. So we can remove this and write y power 3 over 2. And then we can take the powers out. So this becomes 3 over 2 log y. This becomes minus 4 log z minus log x. And this is the correct final answer here. For the next set of examples, we are trying to expand again. So these are further examples on the same thing. Let's take the numerator with a positive, so log z power 3 minus log y power 2 minus log x. So 3 log z minus 2 log y minus log x would be the correct final answer. For the next one, we have log root y power 5 plus log z power 4 minus log x power 5. For the term with the root, we can rewrite it as root y power 5 equals y power 5 all power half equals y power 5 over 2. So this becomes y power 5 over 2. We get 5 over 2 log y plus 4 log z. The power goes to the left, minus 5 log x as a final answer. Again, we have log y power 3 over 2. I just did this very quickly here. So this is y power 3 all power half, which gives us y power 3 over 2. So log y power 3 over 2 minus log z power 4 minus log x. And we kick out the powers. And this is our final answer. For the final set in this video, we are given log A equals 12, log B equals negative 12, log C equals negative 6. Find log A power 4, B power 5 over C power 8. So we have log A power 4 plus log B power 5 minus log C power 8. We kick out the powers, so we get 4 log A plus 5 log B minus 8 log C. And then after getting that, all you have to do is just plug in these numbers. So this is 12. This is negative 12. This is negative 6. All you have to do is just compute the result, which ends up giving us 36. For the second one, we can first expand it as log C power 5 over 2. Again, root C power 5 is C power 5 all power half, which is C power 5 over 2. So log C power 5 over 2 minus log A power 5 minus log B power 4. Take out the powers, so 5 over 2 log C minus 5 log A minus 4 log B, and substitute the values. So this is 6, and this here is 9, and this here is negative 8. So 5 over 2 times 6 minus 5 times 9 minus 4 times negative 8. And this gives us 15 minus 45 plus 32. On the calculator, you can get that. The answer is 2. For the last one, we have log root AB power 3 over C power 9. Now, the root here is covering both A and B, so we can rewrite this as log A power half B power 3 over 2 over C power 9. And this becomes log A power half plus log B power 3 over 2 minus log C power 9. We kick out the powers. We get half log A plus 3 over 2 log B minus log C. And we plug in the values. Excuse me, minus 9 log C. I didn't see that there. So we plug in the values. We have half multiplied by 4 plus 3 over 2 multiplied by negative 2 minus 9 multiplied by 1. And we can compute. We get 2 minus 3 minus 9, which is negative 10. So the final answer is negative 10. This brings us to the end of our video. I hope this has been beneficial. Thank you for watching.